Hi everyone. Welcome to my talk. We are going to talk about boosting your Android CI through integrating build cache. Let's just have a quick look at the agenda. Very first, we are going to talk about me. I'll give a bit of an insight what I did so far in my life with my career and what I'm doing right now at Bitrise. Then we are going to look at the first steps of integration and do a bit of an intro to build caching. After that, we are going to look at how you can improve your caching setup. We are going to look at a real-life example for this. And based on that as well, we are going to expand our view a bit and look at all the different common issues that can come up. And some of you might see there are a couple of plushies down here. These are also up for giveaways. We'll have 3 questions throughout the presentation where you will need to raise your hand, and the first person will get a plushie. So let's jump into it. Yeah, about me. So I'm Tamás Bazsonyi, working as a solutions engineer at Bitrise. I initially started my career as a full-stack developer. After that, I moved into the manual QA space and worked on test automation as well. Then I moved over to mobile development, both on the Android and the iOS side. And at Bitrise, I started my career as a technical support agent, worked with quite a few people, quite a few of our customers, and quite a few people attending Android Makers right here today as well. So it's great to see those familiar faces. And for the last 3 years, I've been a solutions engineer at Bitrise, where I'm basically focusing on those customers who are in the sales pipeline and ensuring that Bitrise really is a long-term fit for them and not just something that they can use for a month and then migrate over to a completely different solution. And yeah, moving over to the very first question. We are going to just look at an ideal case and how much build cache can impact the performance of your builds. So hands up, who thinks it can be 50%? Oh, no hands. Okay. Who thinks 70%? Uh-huh. Awesome. Who thinks 99%? Mm-hmm. And who says 95%? 95 is the correct. I think you were the first one, so I'm just going to hand this out. Yeah, so the correct answer is 95%. In an ideal case, build cache can improve the performance of your builds by 95%. Let's look at remote caching. What is it, and basically how it helps people in their day-to-day jobs. A remote cache is basically a tool that is used by a team of developers and or a CI system to basically share the output of the given tasks that are running during the build process. Let's look at the flow. Yeah, you can see right here, we are looking at 2 different flows. One where the developer is triggering a build on the CI system, and the other one is running locally. So on the CI system, we are basically starting the build, then this would trigger the download of any kind of unchanged task outputs. And after that, the CI system itself is pushing back the cache outputs, task outputs to the caching system itself. On the local machine, basically the same thing is happening. So the developer is starting the build, unit test, then the system itself is looking for any kind of outputs that match the inputs generated hash for the given task. If there are, it simply downloads those artifacts, and this basically gets reused during the build process. Yeah, why would you use remote caching? Is it worth it? It definitely is. Like, as we just heard with that ideal case example, it can make your builds exponentially faster. The consistency and reliability for large teams are quite heavily improved. And of course, having faster builds ultimately improves the developer happiness as well. But when you are implementing, there are a couple of bottlenecks that you definitely need to take into consideration. Just to mention two of these, one is the speed. So instead of having the hardware, where you are pushing up the CPU count, the RAM usage, you would need to ensure that the network configuration is correct, and you have a stable internet connection, which is quite fast because you are replacing those heavy computation tasks with network communication when you are just downloading the outputs. This can be affected by the distance from the build server and the cache server. So, for example, if your caching server is located on the west coast of the United States, in the US you would be getting quite good results. In Europe, those would be like moderate results, and further away, it can even make your build slower than they were originally. And the other part is the implementation time. So ensuring that all of these configurations are correct, your cache server is set up correctly, and the hosting is set up correctly, it can be quite time-consuming. Just to talk a bit about what we are doing at Bitrise on the caching front. As we are hosting the CI solution and the cache servers as well, we are able to co-locate the caching and build servers. And this is why, for example, you would be able to reach that 95% improvement in terms of the build time. This speeds up the CI executions quite heavily. We also have a CDN solution, which allows you to basically get quite similar results on local machines as well. And you are not limiting your caching initiatives to only the CI side of things. And the whole thing is fully managed, so you don't need to take care of the hosting side of things, the setup itself. It's all done by Bitrise. And let's go to another question. So, how much faster do typical builds get using remote caching? By typical builds, we are thinking of builds that you are starting during your regular development days, for example. Who says 5 to 10%? Who says 30 to 60? 50 to 99? And 99 plus? It's 30 to 60 when there are larger modifications. I think you were the first, so congratulations. Yeah, so based on our experience with quite a few of our customers, Even with any larger modifications to their code base, they were able to get in that 30 to 60% improvement. Of course, if you start modularizing your project and optimizing it, you can quite easily increase the impact of the build cache itself. And now that we talked about how build cache can impact your performance during the builds, let's talk a bit about an example. So we were looking at the Amaze file manager GitHub project and started to run a couple of builds on this specific setup. The original build duration that we had was around a bit more than 28 minutes. But after we started to analyze the given tasks, we managed to push that down to 3 minutes, 48 seconds. Yeah, and basically what we were using is a critical path analyzer where we are looking at the different Gradle tasks that are running during the build, identifying which are dependent on each other and which are the ones that are basically taking the longest. And let's have a look at how this looks. So this is a Gradle task graph that you can see here. If you look at the top, we highlighted in red one of the given paths that is basically taking the most time. And this is the main reason for the execution time to be that high. Yeah, and yeah, so let's look at the Gradle critical path analyzer. Basically, the critical path analyzer allows you to see which tasks are exactly the ones that are taking the longest and how these tasks depend on each other. Basically, if you know which are the given tasks that you need to pay a bit of extra attention to, you will be able to start debug further the builds, look at the different inputs that those given tasks are receiving, and based on that, you will be able to optimize the execution and make that given task much more cacheable. Yeah. And just looking at some of the common issues that we were bumping into. So in that specific example that I just showed, the version code was the specific input that was always changed before the execution, and this caused that increased amount of time of run. Basically, if your tasks are dependent on the version code, the version name, then it can quite heavily impact the cacheability of that given task. You always need to update the version code and the version name, of course, if you are deploying to the different stores, generating a new build. So this is something that you would need to have in the build process itself, but by the correct placement of this update, you can quite easily improve quite heavily the execution time itself. Another point is dynamic environment variables. It's partially linked to the version code itself. On Bitrise, we quite frequently see that the version code or version name also contain the build number, which is a dynamic environment variable as well. These environment variables in the build's configuration file itself can change between different executions. So for example, if you are using something that is specific to the machine that is running the execution, if you are getting another machine, that would make the execution itself uncacheable and would always need to rerun that specific task. Yeah, the other part is the Gradle and the Android Gradle plugins. With older versions, we saw that there are quite a few tasks that weren't cacheable, but with the latest plugin versions, the cacheable task count is basically much higher. Another one is the Fabric plugin and Crashlytics. These have a default behavior of treating each version with a separate build. So these quite heavily affect the task execution as well. If you are able to disable the Fabric plugin or the Crashlytics plugin for the test executions where you are also using remote caching, that can impact quite heavily the execution. And another thing is the Jetifier that we saw can quite heavily impact the caching success rate as well. All right. And the last question for the day, for the last plushie, how much time does it take to set up build cache? In this case, we are specifically looking at on Bitrise. Who says it's around 10 minutes? All right. Who says 2 weeks? 2 months? And more than a year? 1, okay. 10 minutes, so we have a winner there. Enjoy.